years. And he kind of mentioned the issue that shorebirds are really, really hard to survey because they inhabit these vast intertidal areas, and that was kind of something that was missing in the picture of shorebird conservation. So with my knowledge and engineering skills to do with drones and software development, I kind of joined forces with Richard and are now doing a PhD that looks at how can we use drones and what are the impacts of using drones, not only in shorebird conservation, but also in bird conservation and wildlife conservation more generally.
Thanks, Josh. I reckon put your presentation up and kick it away. I'm very keen to hear about your research.
Awesome.
Also, if you have questions, please post them in the chat. We will give Josh some time at the end to answer those questions. And I think he'd be quite happy if you got in touch with him afterwards as well, if you have some thoughts.
Yeah, definitely. Okay, so can everyone see the slides? Dylan, is that working properly?
Yeah, that's looking fun to me.
Okay, so as I just said, I'm Josh Wilson. I'm working with the University of Queensland at the Fuller Lab under Richard Fuller, but also my project's supported by the Moreton Bay Foundation and the Queensland Wader Study Group. Both organisations are involved in conserving the Moreton Bay environment and shorebirds. So I'd like to begin by acknowledging the traditional owners of the land and paying my respects to their elders past and present. And I extend that respect to any Aboriginal and Torres Strait Islander peoples that are here today. I'd especially like to thank the Quandamooka Yulubarabi Aboriginal Corporation, who are supporting my research and love receiving regular updates on my work and hope to incorporate some of the outcomes into their management plans for the Moreton Bay area. So essentially, surveying wildlife and getting accurate data on wildlife abundance and distribution is essential to implementing effective conservation action. But sometimes we face barriers to conducting accurate surveys. For example, wildlife can inhabit areas that are hard to access and that can be quite expansive. And in these cases, surveys can be difficult, and using drones presents a method to overcome these barriers and get that accurate survey data and implement more effective conservation strategies. But at the same time, drones present a novel source of disturbance, and we know that disturbing wildlife can have adverse impacts.
Josh, sorry, we're still on your cover slide.
Yeah, that's okay.
Okay, yeah, cool. Just checking, sorry.
Yeah, I've tried to minimize the amount of slide changes I do with the low internet connection. So basically using drones is a balance between between the benefits of getting more accurate data and the disadvantages of potentially disturbing wildlife. So the project was seeded in shorebird conservation. So shorebirds are a group of birds commonly found on wetlands and intertidal areas, wading through the shallow waters and feeding on the nutrient-rich organisms that live on what appears to be a desolate mudflat. One of their most remarkable traits is that they migrate tens of thousands of kilometres each year from Australia, or the ones that live in Australia migrate from Australia up through the Yellow Sea area and right up to the northern reaches of Russia where they breed. But unfortunately, what we've seen in the last 30 years is that some shorebird populations are significantly declining. So here we've got abundance, the counts in Moreton Bay of 3 different species of shorebird, the eastern curlew, bar-tailed godwit, and the great nod. And we found that in the last 30 years, they've significantly declined. And that's primarily due to the degradation of their habitat throughout their migratory flight path. In particular, in the Yellow Sea area, we've seen a loss of about 70% of intertidal areas in the last 50 years. So One of the reasons why it's so hard to find out these the impacts, the predictors of shorebird population declines, is because it's really hard to survey shorebirds as they spread out over vast intertidal areas to feed. Typical survey methods are conducted on foot using binoculars and scopes and tally counters and counting them in real time by eye. And it's not practical for some of the more remote locations like up in the Gulf and these massive intertidal areas. So here we have a potential application for drones where we can access these remote and vast locations and get survey data. But at the same time, these birds are already vulnerable. Their population's already declining significantly, and some of them are critically endangered. So the consequences of disturbing them are even higher, especially for migratory species that need to conserve energy and build up their food supplies to conduct these massive migratory flights. So here we have a clear example of there's a lot of potential for drones to do good, but at the same time, there's a lot of potential for the drones to have harmful impacts. And my research initially focused on finding out whether that balance, whether the benefits of using drones for shorebird conservation outweigh the costs. So the first step was to conduct a literature review looking at previous studies that look at bird and drone interactions in general. And we found 120 studies. Most of those focused on water birds like geese, ducks, swans, or heron, egret, and bittern, as well as seabirds like gulls and terns and skimmers and penguins. Very few of those studies looked at shorebirds, which was surprising given the consequences of shorebird disturbance and the potential benefits. So, for example, we found no studies that looked at those three birds that I mentioned earlier, the eastern curlew, bar-tailed godwit, and great knot. So we decided to do our own research and find out a bit more information about the interaction between drones and these species of shorebird. So we went out to flocks of shorebird, like the one you can see as the background here, which is a flock of eastern curlew. There's some pied stilts in there as well, at Tourville. And we recorded the birds with a video camera mounted on a tripod at the same time as we flew over them at different altitudes with a drone. And as the drone's flying, it logs its position and speed and a number of other parameters. And we synchronized those parameters with the video logs so we could then analyze what drone behaviors induce disturbance in the birds. So we used 4 different types of drones. Larger drones like the Inspire, the grey drone you can see here, the larger Inspire 2 DJI drone, are larger, louder, but they can carry better cameras, so they may enable us to fly higher, which may result in lower disturbance. And on the other end of the spectrum, we have the DJI Mini, which is a really popular drone. It fits in the palm of your hand. It's only 250 grams. There's basically no regulation around flying this drone almost anywhere, but the camera on it's not so good. So if you're using it for survey methods, it might not be appropriate unless you're flying at really low altitudes. But in the middle, we have the Mavic and the Phantom, which are really, really common consumer drones. They're the drones that you'll see being flown probably illegally in national parks and around in holiday destinations and in parks, and these drones are ubiquitous. They're all over the country now. So it's really important that we understand the impacts of those consumer drones as well. So we ended up performing 300 approaches, and we focused on those 3 species where the literature was lacking: the bar-tailed godwit, eastern curlew, and the great knot. So we then analysed the results, looking at the probability of the birds taking flight with different drones at different altitudes and with different bird species. And what we found was that the response, the disturbance increases as you get closer to the birds, which is intuitive, as you fly lower altitudes or you closer horizontal distance. We also found that it depends on the drone you use and it depends on the species. All of these results were intuitive, but our data backed that up. So first of all, we looked at the bar tailed godwit, and you can see on the x-axis here, I have the altitude of the drone, and on the y-axis, I have the probability of causing the birds to take flight. And once you're above about 50 meters, the probability of the birds taking flight is low, about 15 to 20%. And once you get below that, it increases significantly, where once you're down around 10 or 20 meters, there's almost 100% chance that the birds will take flight if you approach them with a drone. But even at the higher altitudes, you're still getting 15% probability that the birds will take flight, which is still significant. And we start to question whether the costs outweigh the benefits of using drones. We got similar results for the great knot, but critically, with the eastern curlew, we found that we never could approach them with any type of drone at any altitude below 120 meters, even using the drone that's only 250 grams, up at 120 meters, we could never approach them without them taking flight. And this was shocking. I didn't expect it. We'd done preliminary studies on other species where we found that we could get fly quite low and wouldn't disturb the birds. So I was shocked when I got this result. And it basically means that eastern curlew are highly sensitive to drone-induced disturbance. What we also found is that when eastern curlew are present in mixed flocks containing other shorebirds, when they take flight, it often causes other species in close proximity to take flight as well. So now we're starting to see a picture where eastern curlew are highly sensitive to drone-based disturbance. Eastern curlew in mixed flocks cause other species to take flight as well. And in Moreton Bay, eastern curlew are present in almost all habitats in mixed flocks. So we start to see that no matter what drone we use, we're going to cause significant disturbance to shorebirds, at least under the parameters that we tested with the drones we tested. And we could only go up to 120 meters. So at some higher altitude, you will get lower disturbance. But basically with all the parameters we tested, we found that drone surveys where eastern curlew are present are not appropriate. And there are probably other species like the eastern curlew that are highly sensitive to drone-induced disturbance. So that was disappointing, but I think it's a really valuable finding as well. So it potentially leads to it means that guidelines and regulations around drone use near shorebird habitat may be necessary. So we delved into a little bit more detail around that interaction between the drone and eastern curlew, and looked at what's called the flight initiation distance, which is the distance between the birds and the drone at the point that they take flight. So on the x-axis here, we have that distance, and on the y-axis, we have the drone altitude. And what we found, which was counterintuitive, is that at lower altitudes, we could approach the birds closer before they took flight, whereas at higher altitudes, the birds took flight when the drone was further horizontal distance away. And this was counterintuitive, and it's interesting information. And we theorize that it's probably because when the drone's at higher altitudes, it's mimicking predator behavior more closely. But we're not sure, but it's interesting data and gives us a bit more insight into that interaction. But we also found through those experiments and through the literature review that there's some species that are not very susceptible to drone disturbance. The literature looked at ducks and swans, and those kind of freshwater birds. And then we found, and also seabirds, and found that the disturbance was quite low. And our experiments backed that up and said that for Caspian tern, gull-billed terns, and even pied stilts, the response is quite low. And if you're flying at 40 meters the birds are very unlikely to take flight. So with that in mind, we did see a potential application of using drones in certain situations. And we then created the aim of developing a process that would enable researchers and park managers to conduct these surveys quickly and reliably and accurately. So that involves going out with a pre-programmed flight path to a survey area, which might be a wetland area, flying the drone, which is done autonomously. It captures the images for you, and then you upload the images to an application that we're developing, And that goes through and detects the birds, labels them with their species, labels their GPS position, and labels the time that you took the image, so the survey time, and gives that back to you in a format that is easy to analyze for research or management purposes. And critically, I wanted this process to be easily accessible and open source so that people can use it and contribute to it. So we're not the first people to use that sort of method. A lot of studies since drones first began to be used have tried to do this sort of autonomous drone survey method. Most recently, people have been using what's called object detection, which is a machine learning technique that's been really prominent in all areas in the last kind of 5 to 10 years. Especially in 2019, in 2021, people used what's called a faster RCNN network to detect birds in drone images. And that was quite successful. The issues with previous studies is that most of the time they only focus on detecting birds rather than detecting the species of bird, which is really important if you're going to have a mixed flock of a critically endangered species with not very endangered species. And you need to know species-specific abundance and distribution. So that was kind of our goal, was to expand on that previous literature to make it species-specific, and at the same time, previous literature hadn't really translated their research into a software and an application that's easily accessible for managers and researchers. So that was my goal as well, to make something that people can use readily without having a bunch of knowledge about machine learning. So the process to do that is to first go out and collect a bunch of data to train the network. So we looked at those birds where we knew the disturbance was low, and we flew over the top of them and took images and then went through and labeled them. At the moment, we have 300 labeled images, but we're working to increase the size of that data set to increase the accuracy of our detections. And you go through and label those images with what bird, the species of each bird. And that's what you use to train the machine learning network. So we've used a faster RCNN based on that literature review because it performed well for detecting birds in drone images. And the structure of a fast RCNN basically involves an initial network called a convolutional neural network, which basically takes the image and highlights the areas that are likely to have significant objects in it. The second stage is called a region proposal network, which looks at the highlighted objects and crops out the ones that are likely to be your object of interest, in this case, birds. And then the final stage is a classification network, which looks at those cropped images and classifies it into different categories of your object of interest, in our case, different species of bird. So we've trained a prototype faster RCNN network on those 300 labeled images. And the final stage is deployment. So basically making an application that is easily accessible, that has this network in the back end so that people can go on, upload the images of the drone-based images of birds, and this algorithm will detect the birds for them and tell them the species, the GPS location of each bird, and the time the image was taken. So we have developed, again, a prototype version of that system, and we're just working on improving it over time with more data and making it more user-friendly. So the prototype is functional at the moment. For example, this is an image of silver gull taken at Manly, along the Manly foreshore in Brisbane. We upload it to the website and it returns this image with each of the birds labelled. And finally, it also returns this CSV document with a label of silver gull, the date and time of the survey, and the latitude and longitude of each bird in the image, which you can then go on to analyse. And that's available now at the link down the bottom. It is a prototype which we're aiming to improve, but it'll give you just an example of how the the system works. So in summary, basically accurate surveys are essential to effective conservation action, and drones can overcome some of the barriers to accurate surveys, such as vast habitats or hard to access habitats. They are often more cost effective and quicker, and sometimes more accurate than ground-based surveys. But at the same time, they present a novel source of disturbance, and we need to analyse the costs and benefits of using drones. The difficulty of surveying shorebirds across vast intertidal habitats and remote locations presents an opportunity for drones, but because shorebirds are declining, many shorebird populations are significantly declining, and their migratory life cycle, the impacts of drone-based disturbance are higher. So we looked into the literature and found that there were very few studies that looked into shorebird drone interactions. So we conducted our own experiments and found that where these sentinel species like the eastern curlew are present, drone surveys are not appropriate for shorebirds. Under the conditions that we tested, which is the non-breeding ground, and with the drones we tested below 120 meters altitude. So there is more work to do there, flying at higher altitudes, potentially using lower drones that are designed to be lower disturbance, and looking at how they react in their breeding habitat. But our research shows that in Moreton Bay, drone-based shorebird surveys are probably not appropriate. But we also found that there's other species of bird that are not as susceptible to drone-induced disturbance. And in this instance, drone-based surveys are appropriate and the benefits far outweigh the costs. So we used those species to develop a autonomous drone survey method that's readily available, that's open access and free to use, and is basically an autonomous end-to-end drone survey method. Future work for us involves publishing the work that we've found on the eastern curlew and shorebird-induced drone disturbance. Drone-induced shorebird disturbance, and then also continuing to work on increasing the accuracy of our autonomous detection method and making it more accessible for researchers and managers. And then the final stage of my PhD will be to use this method to go out and survey a bunch of birds in wetlands and just find out the performance of the method, find out any issues that we're having with it, and try and really prove that it is a appropriate way to survey birds. So that's the end of the presentation. If you would like to get in touch with me, I've put my email up on this last slide. If you want to be involved in shorebird conservation in general, you can contact the Queensland Wader Study Group. If you want to know more about my research or be involved in conservation in the Moreton Bay area, you can go to the Moreton Bay Foundation's website. And for updates on the project, you can go to the project Facebook page where I post regular updates on what I've been up to and sometimes nice pictures of birds as well. And down the bottom, I've just got some references that I use throughout the presentation. So thank you very much for your time, and I hope it's been informative, and feel free to ask any questions now or email me through any questions, if you want to touch base.
Thank you very much, Josh. That was very interesting, and I think having been exposed a bit to things like machine learning, you managed to make that understandable and simple pretty well, so I appreciated that. We've got some questions rolling in. I've got a few myself, but I'll save them. So the first one, straightforward question from Jason Wilson. Jason, did you want to ask that question directly?
Yeah, look, I don't mind. Yeah, great stuff, Josh. Out of here at Narran, Guada, and the Macquarie wetlands, or marshes or lakes, they're doing a whole suite of drone footage on some of the nesting that is occurring, the breeding. Is your tool or the methodology, can it be, exported or used on other people's data sets?
Definitely, that's the idea of making the tool free to use and open access, is that I want people to take their own data and upload it to the website, and it'll perform the detections for you, provided that I have at some point had images containing those birds before. So it will take time to improve the network to the point that it can be used, on many different species. At the moment, it only works on a few different species. But one other thing I would love is if people have got images of birds that are captured from a drone and are willing to share them with me, that can be used to train the network and improve the performance of it. So if you've got a bunch of people taking photos of birds with drones, I would love it if you could share that data with me, and in return, you could improve the quality of the detections for that species of bird.
Excellent. Okay, Paul has Swapan. Sorry, Swapan has a question on wondering why Eastern curlews are scared of drones. Swapan, did you want to ask that question yourself?
Hi. Yes. Thank you. Yeah. Great talk, Josh. So, what aspect of the drone is the issue? Is it the shape, size, or very physical aspect of it, or it is the noise that it makes, or both? What do you think?
What we found is that the larger drones did increase disturbance, but the larger drones are also louder as well. So I'm not sure if it's the increased size or the increased noise, but with the 250-gram drone flown up at 120 meters, it's really, really small, and you can hardly hear it at all. So we're basically not sure. It's something to do with the noise and the novel stimulus. And for some birds, they don't mind at all, but the Eastern curlew in particular, whether it's the frequency of the noise, that's definitely some work I would like to do in future to really nail down what it is that causes that disturbance. But definitely larger and louder drones cause more disturbance. But I'm not sure what aspect of those things, or whether it's a combination of the size and the noise that's contributing to it. I would love to do research that really nails down what it is about the drone that's causing the disturbance, so that people can go on to design drones that are specifically low disturbance for birds. So yeah, it's an interesting area. We found out a little bit about what aspects of the drone cause more disturbance, in that louder and larger drones cause more, but there's still a lot more work to do in that area.
Absolutely. Thank you very much.
Thank you for the question.
I have Anthony's got a question, but I've got just a quick follow-up. If the hypothesis is that it's mimicking sea eagles or kites or other kinds of birds of prey that are hovering quite far above, are you considering doing surveys where you basically approach from close to sea level and basically survey around the site where the shorebirds are? And I guess if so, would that completely screw up the identification using machine learning if you're photographing them from a different angle?
So the machine learning, the object detection at the moment that I'm doing is only based on photos that are taken almost vertically. So yes, in my case, it wouldn't work on birds at an oblique angle. The reason I've done that is because the aim and the goal of my work was to develop a method where you could go out and you didn't know anything about the site, because it could be 2 kilometers away, and just press go and the drone would fly out and survey that area in like a grid pattern. So you may be flying directly over birds, you may be flying, you may be potentially flying directly over birds that you don't know what species is there. So that's why we focused on that method. But I think that one potential solution to the Eastern curlew problem, if you know where the flock is to stand back and take an image at an oblique angle and use that data. But even then, you have to be quite a long way away. We found that, as you saw in that plot of the flight initiation distance, if you're up at 120 meters, the birds are flying away when you're almost 200 horizontal meters away. So the image quality is going to be quite low at that point. But yeah, there are options to take those oblique angle images and develop a different type of machine learning algorithm that works with kind of those oblique angle images. And actually, probably the detection of the species would be easier with those images because you get more information about the birds, about their shape and stuff. When you take a vertical image, they all just look like different colored blobs, basically. But
yeah, cool. Yeah, thanks for that. That actually fills in a lot of the blanks. We've got another question from Anthony. He's asking about sea eagle interactions. Anthony? Well, I might just.
Here he is.
Hi there. Sorry, it took me a minute to get on.
Sorry.
And I'm just a blur by the looks of it. I noticed that there have been interaction with eagles and drones in other countries and here. And I know personally I've had interactions with sea eagles when just simply flying a kite on the seaside. And I'm just wondering whether or not you've actually had any sea eagle interaction at all with your drones.
So in our literature review, we found studies discussing exactly that, aggressive behavior from seabirds and from sea eagles and predatory birds towards drones, even magpies and that sort of thing. So our policy when conducting these experiments was that if we saw a sea eagle, we landed the drone immediately, just to avoid any damage to the bird or damage to the drone. So we didn't get any interactions, but only because we were vigilant and avoided them. But there have definitely been studies and, as you said, personal experiences where drones are taken down or aggressive behaviour towards drones from those kind of eagles and kites and stuff.
Yeah, so it's reliant on the observer's observation rather than a mechanical or machine learning in being able to intercept.
Yeah, in our case it was. I think it would be hard to develop something that monitored the airspace around the drone and detected aggressive behavior from birds and then landed the drone. Most drones do have obstacle avoidance, but I don't know how that performs with an eagle coming in to attack the drone. So yeah, I've just relied on myself, and normally when I'm doing experiments, there's someone else there and we're monitoring the area around the drone to make sure no birds are getting too close to it.
Yeah, thanks.
Maybe there's a military technology or software that's being developed that can help with that in 5 years when it gets released to us. Ethan had a pretty detailed and probably important question around how you managed animal ethics. Ethan, did you want to ask that directly?
Yeah, sure. Hey, Josh, thanks for that. It was really useful and quite interesting. Just some background. So yeah, we've got a community of practice here in Dore looking to produce some guidance on the use of drones in animal surveys. So not just shorebirds, but also inland birds and other animals. Just kind of going to your point about the fact that there isn't really a big cumulative body of knowledge yet. Just wondering how the ethics approval process was sort of handled for your project, like what sort of things the ethics committee were interested in knowing about and like how they handle that and whether or not there's any indication of what direction those sorts of questions are going to be, how they're going to be asked and how they're going to be answered.
Well, because of the lack of research around shorebirds, the ethics committee was quite excited about my research. So I apply for ethics through the University of Queensland, and there's a review process that you go through for any kind of work that involves animal use. And they were interested because my project is aiming at doing something similar to what you're doing and developing guidelines for using drones around wildlife. So as long as the outcomes of the project were focused on developing guidelines that they could then reference in future for future studies to minimise the disturbance caused to shorebirds through drones, then they were happy with it. Their main questions were around what's the lowest altitude you will go to avoid the event where the birds take off and collide with the drone. So we limited that to 20 metres. And also, anytime the birds took off, we immediately flew the drone vertically upwards away from the birds and then back away and finished the experiment to avoid those collisions, but also so that the birds could come back and land at the same place quickly and not expend too much energy. So I guess, yeah, there are a few things there are a few guidelines that you can follow so that you minimize the disturbance, things like the altitude you're flying at and what your response is if the birds start showing disturbance behaviours. A lot of the time we would see agitated behaviour before the birds took flight, and if we weren't doing a study that needed to invoke disturbance, then you could then monitor the birds, see those kind of agitated behaviours and move away. But yeah, UQ is still in the process of developing guidelines for drone use around shorebirds, and my project is part of that. So there wasn't very many regulations around it already, and hopefully in future there will be more regulation around that.
Great.
Yeah,
thanks. That's really helpful.
Sorry.
No, you're right.
Okay.
Sorry, Ethan, to talk over you there. Yeah, and thanks. That is useful. And I think it's probably worth talking to state governments about the regulatory frameworks they have for drones and animals at some point. I think I'll say this is the last question from Kayla. And then if you've got any further questions, please just contact me, Catherine, or Josh. I'd encourage you to contact Josh directly. So Kayla has a quick question around disturbance and the relation to weather. Kayla.
Hi, Josh. I guess I can turn my video on as well. Thanks so much for the talk. I was just wondering if you'd noticed any disturbance in relation to weather. So I assume if it's cloudy, it would change kind of the shadow of the drone. And did that have any influence on how birds reacted?
So we did record, so when you fly the drone and you get the drone log, you often, along with that, get, well, you can then access a bunch of weather data like the temperature, the wind speed, the cloud cover and that. And we have done that for each of the approaches, but we're yet to include it into our analysis. So more to come, I guess. I'm hoping to find out more about that area, but you know, with each new source of variance sort of that you introduce to the study, you need more and more data to kind of tease out what is important and what's not important. But yeah, I know that you were hoping to do a study that's similar, and I think, yeah, when you do your drone logs, you can basically upload them to, I use the site called Air Data, which converts the log into like a CSV format. And on that same site, it lists all the weather data as well at the time of flight. So that's what I use to get the data, the weather data for each flight that hopefully we'll be able to look at further down the track with analysis.
Okay, awesome. Thanks so much.
And just on that point, it's Kathy here. I had a bit of a chat to Josh before we came into the meeting, and the brilliant stuff about his PhD is that he's got another sort of 18 months to 2 years to go. So I think we'll get Josh back this time next year to see where he's at, because I think like the feedback has been amazing, Josh. And yeah, we want to see where you're heading with it.
I think there are plenty of other. Sorry, Josh. I think there's plenty of other places where you could roll this kind of work out too. So I agree. Yeah. All right. Sorry. Thank you very much for presenting, Josh. Much appreciated. Did you have anything final that you wanted to add?
Thank you, everyone who joined and listened. It's amazing to have such a huge platform and to also be working with other young people engaged in wetlands. If anyone has any drone-based images of birds, I don't encourage you to go out and fly a bunch of drones everywhere, but if you're already doing it, send them my way. That would be great. Yeah, and if you have any questions, just email them through. I love kind of having that discussion, and you know, that's one of my fears with doing a PhD is that you end up doing something that is a thesis and doesn't really get used. So I'm excited about trying to transmit my research into action and into you know, impactful outcomes. So yeah, if anyone wants to know more, please get in touch.
Thank you very much, Josh, and sorry for interrupting before. Yeah, that was great. I am also keen to see this kind of research lead to policymakers kind of either regulating around where you can put drones around wildlife, but also using it to collect data more efficiently, maybe linking up with some other wetland projects around Australia. Much appreciated. I got a lot out of that. Our next talk we will send out some info about in the next couple of weeks, but it should be someone from ANU, from Janie Pittick's group. He's got a few different students who are working on flows out of the Snowy Mountains and in the Murray-Darling Basin, so more details to be confirmed. We will be getting a group of young people engaged in wetlands, youth engaged in wetlands together in a couple of weeks to discuss what we can do in terms of getting voices heard by decision makers, by policy makers, feeding that into the Ramsar COP at the end of the year, as well as building a community of practice. So please get in touch or put people in touch. Otherwise, thank you everyone for coming. Yeah, I think this has gone really well. Michelle, we will put up the recording at some point. I will get back to you on that one. But yeah, thanks everyone for coming.
Big thanks, Josh. Thank you.
Yeah, thank you. Fantastic.
Thanks.
You've got all of these. Josh, you've got lots of comments that you just stay online and have a look at those. I was just thinking as you were presenting, it'd really be fabulous to have this research presented across the flyway. So with our Chinese, Korean, Japanese colleagues that are managing shorebirds.
Yep.
Unfortunately, Mark Carey and Narelle, I don't think were online. You didn't see them there, which is disappointing, but they might have had other things on. So if you're happy, we'll try and set something up. In fact, you might want to even do it through your own networks. You people.
Yeah,
so
sure.
Have you got people in China, Korea?
We've heard from people in Korea, not so much China. Japan, we actually have an ongoing relationship with. It's called Eco Youth Yatsushiro through the Ramsar Network Japan. Mm-hmm. So they're a group of high school and university students who work on the river mouth and the floodplain specifically. So we meet with them regularly. Mm-hmm. And then there's broader links with Ramsar.
So we know Doug Watkins pretty well. He's the conservation officer for the flyway. So what I might do is I'll see if he can actually listen to the recording and provide him with your email, Josh. Rich is probably also in touch with a number of those stakeholders as well, but I think it'd just be fabulous.
So we are hoping to publish that work very, very soon, or submit it to be reviewed. And I think that sort of thing would coincide very well with the publication of that information. Yeah. So I think if we start trying to set that up now, then we can align some things so that article comes out and then we do a bunch of those presentations.
Would it be worth trying to do that officially through the East Asian Australasian Flyway Partnership? I know.
That's through Doug.
Yeah. Okay. Sweet.
Yeah.
Cool.
Yeah. And Mark Carey and Narelle. The other thing I'm thinking about, and this is just hopping forward to the COP and assuming you guys have got a bit of a side event going.
Okay.
It is to have some of this stuff, this regionally relevant stuff that underpins our international agreements like those migratory bird agreements. And even if Josh isn't there, we can zoom him in or whatever. So
I think a hybrid event, and maybe if he can, he'll probably have a poster of some kind put up as well. Things like
or
that.
get some money to travel to Wuhan with us.
It's not far, actually.
Because the other thing about you going to Wuhan is that you can do a bit of a bit of work on your PhD on some of their, visiting the site managers. They've got a great site managers network. So have a think about that. That'll be in November.
That'd be amazing.
We want a young people's revolution at the COP. So the more of you in the space, the better.
I think that'd be good. We should extend something similar to the presenters throughout the year, maybe have a bit of a delegation.
Yeah.
That'd be really cool. I know Rich's lab has been in China a bit, so they have connections. So.
Yeah.
Cool. Thanks so much, Josh. That was really good.
Yeah, thanks, guys. I'm just trying to figure out if I can save the chat. Does anyone know? I'm Googling it.
I think I can cut and paste the comments out for you.
Mine stays around too, so we can definitely do that.
And did you see the stuff about the pelicans and the Coorong and some of the other stuff?
I did see that. I would love to get a bunch of photos of pelicans, yeah.
Yeah, well, Dylan's our new one dealing with the...
Yeah, I deal with SA government who work on the Coorong most days, so I can chat to them. The science team...
I don't know if Jason Hyman was online then too. But, yeah.
Yeah, well, there's the Goiter Institute down there. Maybe you could even collaborate with them. Bruce?
Thanks all. My apologies, Josh, for not being able to listen to the whole presentation due to several interruptions.